Okay, 2022, question 9. Alex gets injections of a medicinal drug. Each injection has 15 milligrams of the drug. Each day, the amount of drug left in Alex's body from an injection decreases by 40%. Now, straight away, if I hear a decrease of 40, that suggests to me that 60% is what's left in the body. And another way of writing 60% is 0.60 if you wish, or 0.6. So the amount of drug in milligrams left in Alex's body, T days, now the units are important, days, so not hours, not minutes, after a single injection is given by the following. So that explains why this is 0.6 in the question. It's because it's what is left in the body. Find the amount of drug left in Alex's body, 2.5 days. Now, this is good news because the units are the same, so we don't have to do any sort of converting. So how much is left 2.5 days after he's gotten the injection? So all we do here really is a fill-in. So we replace the T with 2.5, work that out on the calculators, 15 bracket 0.6, and we're raising that to the power of 2.5. Okay, so that's giving me 4.1828. Now we're supposed to correct to 2 decimal places, 4.18 milligrams. So that's what's left after 2 days. Part C. So Alex is given a 15 milligram injection of the drug at the same time every day for a long period of time. So this is an injection that you're not getting like a once-off, like maybe a vaccine or maybe an antibiotic treatment or something. This is something like almost like a diabetic medication, something that it happens every day. Explain why the total amount of drug in milligrams in Alex's body immediately after the 4th injection is given by. Now, if we think about this just logically, if I've had 4 days of injections, the only time I get the full whack still in my body is the last one that I've taken. So straight away, I know that 15 there has to be the 4th day, because once the 4th day is over, or even once I've taken the injection, it already starts reducing. So this has to be the 4th one. Now, if we look at the second part here for a moment, if I was to translate that, that is 15 by 0.6. So really, it's 60% of 15. Now, I guess that makes sense from what we did in part A, because I have that much left in my body after I've gotten that injection. But when you look at to the power 2, it's like saying you're getting 60% of 60% of 15. So in other words, you're getting 60% of 15, and then by the following day, you only have 60% of that left. And then the same applies here. You're getting 60% of the 60% that's left, of the 60% that's left. So that is why, that explains why we have a power of technically 1. I know it's not written there, but that's 1, power of 2, power of 3. So it's talking about your 4th injection, your 3rd, your 2nd, and your 1st. So by the 4th day, when you look at when you think about or analyze your 1st injection, you only have 60% of the 60% of the 60% left by the time it gets to day 4. Whereas if you look at your 2nd injection, well, you would have 60% of the 60%. And why are they being added together? Well, why is there a plus in between each term? Well, there has to be a plus, because whatever's left over from the day before accumulates in the body. So it's not like it just evaporates, it's all accumulating. So you will have a little bit left over from the 1st injection by the time you get to day 4. By the time you get to day 5, you will still have a little bit of injection 1 left over, but it gets smaller and smaller and smaller, because you're getting 60% of 60% of 60% of 60% and so on. So I hope that explains it, that you understand it. Any questions, you can let me know.